Hi everyone, welcome to week 8. We're going to continue working with trigonometric functions or trigonometric ratios. This week we're going to focus on trigonometric functions of any angle. So far what we've done is we're working with right triangles where this particular angle that we call theta lies between 0 and 90 degrees, meaning the triangle look like the following. Now what if the angle is more than 90 degrees? What if we have certain triangles where the angles are more than 90? What happens in that case? Now recall, previously we learned that one full circle equals 360 degrees, so that the angle theta can take a value between 0 and 360. Recall, this is 0, you go all the way up here, that's 90, you go all the way down here, it's 180, go all the way here, that's 270, and then you go all the way here, which is 360. A few prereqs or a few things that you need to know before we continue is called a coordinate system. Coordinate system consists of two perpendicular lines, or you can say two perpendicular number lines with the following properties. If you move to the right, so this point here is 0. Yeah, this 0 point is also called the origin. From the origin, if you move to the right, the values are positive. If you move up, the values are again positive. If you move down, the values are negative, and if you move left, the values are negative. Now these values, the horizontal one, that's the horizontal one, are called x values. And these values which are vertical, well, they're called y values. Now, any point on the coordinate system, aka the grid, can be identified as the pair x, y. X is the horizontal position and y is the vertical position. Now let's look at an example. For example, let's say 2, 3. It's 1, 2. Right? So that means the x value, that's the x value, and that's the y value. So it's 2 distance away in the horizontal and 3 distance away in the vertical. So that point is right here, and we write it as 2, 3. Negative 2, 3. So it's negative in the x, which means I move to the left. Now when I move to the left, I have negative 1, negative 2, and right up here is negative 2, 3. 2, negative 5. So x value is positive, the y value is negative. Let's say that's negative 1, negative 2, negative 3, negative 4, and negative 5. So that's going to be right here. That's 2, negative 5. And then negative 2, negative 3 is right here, where both x and y values are negative. When we draw this grid, we create 4 distinct regions. These regions are called quadrants, and these are numbered counterclockwise starting from the top right. So that this is quadrant 1, where you notice x is positive, y is positive. Quadrant 2, x is negative, y is positive. Quadrant 3, x is negative, y is negative because you're left and down. Quadrant 4, x is positive, y is negative because you're right and down. Next thing you need to keep in mind is that when we learned about angles, we said that angles are measured counterclockwise. Now when you measure them counterclockwise, they are positive. And if you measure them clockwise, they are negative. For example, this line here, we can say, has a positive measure of 125 degrees, or if we go the other way around, it has a negative measure of 235 degrees. They identify the same line. Okay, so why is this useful? Is because we can have triangles or right triangles in each of the possible 4 quadrants. The points where the line meet, that's called the origin, we've already seen that. Any right triangle can be constructed so that the hypotenuse extends from the origin to a terminal side. Example, if the terminal side is 3, 4, that's the right triangle. And then we know that this length is 3, and we know this length is 4, which means I can find the hypotenuse as x squared is 3 squared plus 4 squared, which is 25, and x is root 25, which is 5. And in this example, you can pause and try this. Draw the right triangle with the given terminal sides. So I draw the axis. That's my origin, 0, 0. The first one is 1, comma, 2. There's my right triangle for 1, comma, 2. Negative 1, comma, 3. That's my right triangle there. That's negative 1, comma, 3. Negative 1, comma, negative 2. It's right there. That's my right triangle for negative 1, comma, negative 2. And then 2, comma, negative 3. It's right here. And that's my right triangle. 2, comma, negative 3. So basically, given the terminal sides, you should be able to draw the right triangle. And then you can see, for example, this is in quadrant 1. This is in quadrant 2. This is in quadrant 3. And this is in quadrant 4. So our next goal is to look at the trigonometric ratios for the triangles in each of these 4 quadrants. That's what we're going to do in the next video.